Hello, my name is Adam, and welcome to another episode of Family Gems. This time we're going to be talking about DNA and doing a little DNA overview for your family history. So, this is a little snippet from FamilySearch.org, how DNA testing helps in genealogical research. Have you ever heard your friends and family enthuse about DNA, but don't know what it's all about? Wondering if a DNA test is right for you? Come learn about DNA, why it's valuable, which tests you can take, and how it might help you in your family history. Okay, so we're going to talk about DNA, and I'm going to refer you here to Family Search to begin with, and then we're going to go into some details. So familysearch.org/en English/DNA testing, or you can just do familysearch.org/DNA and it will come up. They have a nice little introductory video about DNA. It's about 2 minutes. I highly recommend you watch it. It's good. It will kind of give you a little overview and give you a little spark of why you might want to try it. They also have 2 categories here: which DNA test options are available and what should I do after taking a DNA test. You have many options in choosing a DNA testing company. Each company offers a different experience and focus. Your choice depends on what you want to learn. And what should you do after taking a test? Have you taken a DNA test but aren't sure what to do with your results? You can use your DNA data in many ways, depending on what you want to learn and accomplish. Here are some suggested options. Okay, so what are the options available? First, you want to choose a company. Each company offers a different experience and focus. Your choice depends on what you want to learn. The following DNA companies include cousin matches to help you explore your ancestry and create family connections. So the top 3 I would recommend in this order is Ancestry DNA, MyHeritage.com, and FamilyTreeDNA.com. So to give you an overview, Ancestry DNA only offers autosomal testing, and I'll go over what that is in a moment. They are the largest DNA database in the world, something like 30 million tests to match against. MyHeritage is a little bit smaller, and then Family Tree DNA is even smaller at about 1 million. MyHeritage is around 8 million. And so if you want to catch fish, they say go fish in the biggest pond. The biggest pond is Ancestry. Small and then medium is MyHeritage, and then smaller is Family Tree DNA. Now, MyHeritage does offer autosomal testing also, while FamilyTreeDNA.com, I would only recommend them if you want to do Y-DNA and mtDNA, because they have the largest Y-DNA database in the world and the largest mtDNA database in the world. And I will be going over what that is in a moment. So here's a little overview of Ancestry DNA. Basically, it's collected by spitting in a tube. So what they do is you order the test, you spit in the tube, and you wait back 6 to 8 weeks or whatever. Could be less, could be more, and you get your results, and you go from there. MyHeritage is similar, only you just put a little cheek swab and scrape in your cheek. Do a similar thing in Family Tree DNA. They also do a cheek swab, and they take 2 samples so that you can upgrade or test later if you want, and I'll go over that in just a moment. So let's read what Family Search says about each of these companies. At Ancestry DNA, the results are tied to your account, your Ancestry.com account, and family trees. That is, if you want them to be. You'll receive an ethnicity estimate that tells you what percentages of your DNA may come from different areas around the globe. You may also be connected with living relatives if you choose to create a public family tree, and they're also registered with the service. MyHeritage DNA. They also test autosomal DNA. They do the cheek scraping, as I mentioned. They provide ethnicity results and cousin matches. They can trace your ancestry to more than 2,100 regions, helping you see and understand the geographic roots of your family tree. Test results show a percentage breakdown of specific components of your ancestry. And then Family Tree DNA, as I said before, they do autosomal, but they also do Y-DNA, patrilineal, which is your father's 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 line. Only men can take the Y-DNA test because only men have the Y chromosome, and it's the chromosome testing of just the Y. And then the mtDNA stands for mitochondria DNA, is for matrilineal research, which is just your mother's 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 line. So it's like the bottom edge of your tree for mtDNA, mother, top edge of your tree, DNA for father. And I'll go over that a little bit later about what mtDNA is. Their autosomal one, their product is called Family Finder. Again, it's collected by scraping your cheek. They provide cousin matches and a chromosome browser. Key elements of the test include the My Origins report, a visual tool to better understand your ancestry. Okay, so just a brief word about DNA in general. So many people have privacy concerns. They might be a little scared of it. So I'm going to tell you this part. It's kind of funny because, I like to tell people we have this illusion of privacy, but we really don't have as much privacy as we think. Just go look in your mailbox one day and see how many companies send you information. And if you ever move and you don't tell them, this amount of your information also. So with hackers and people who have lots of malicious actors throughout the last decade or so, your information is probably out there on the internet in some form or another. So combine that with Facebook and social media and collaborating, and we don't have as much privacy as we like to think. Now, apart from that, you can, as far as connecting your DNA to yourself, you can just search and leave your results private. Depending on the company, they have different options to do that. Family Tree DNA has an option for law enforcement searching opt-out. So if you say opt-out, then they won't allow law enforcement in. Ancestry DNA and MyHeritage DNA also are places to test. There's another company called Living DNA. They also provide ethnicity estimates, including an advanced sub-region breakdown of genetic origins in the British Isles. The site connects you with relatives with whom you share DNA. Results include DNA, which is autosomal DNA, Y-DNA, and mtDNA collected with the cheek swab. The DNA registry covers 150 geographic regions and then zooms in on hundreds of subregions. So I've done my DNA tests at all of those sites and had a lot of my family members do it. I do highly recommend it. I've done Living DNA. They only have about 300,000 people to match against. They're mainly for British Isles and that region. They're just not quite as popular in terms of, they just don't have as big of a critical mass. But you might find things there. They do have Y-DNA and mtDNA, but it's just a smaller match. Okay, so what should you do after taking your test? Depends on what you want to do. And then there's also a frequently asked questions and terminology. I'm not going to go too deep into the technology and terminologies, but I will go over some high-level information. So what do you do to use your DNA test to make genealogy discoveries? If you're not sure, here are some suggestion options. 1, create or share your family tree. You'll have a better experience discovering your DNA and connecting with relatives if you share your family tree on the testing company's website. Number 2, identify how you want to use your DNA to learn more about your family. Okay, so DNA tests will give you results on things like ancestral homelands, which is your ethnicity. They can help you break through brick walls. You can find cousin matches, and you can also do what's called chromosome matching. You can also find information about adoptions for adoptees or people who have placed children for adoption and they may not know where their child went to. Okay, so I'm going to start with ancestral homelands and go over that just a little bit. A lot of people who do DNA tests are really interested in that. Like, do I come from Ireland or Africa or England or South America? And that's really all they care about. So a lot of people on Ancestry or these popular sites, they won't do a lot more other than just put their name in. So that is not as helpful. DNA is just raw data. You got to connect the data to something, put it in context. And there's 4 letters of DNA, A, C, T, G, and I'll go over that a little later, but it's just repeated millions of times, and it's just information. Now, when you connect it to your tree and you put it in context of a name, a family, a person, a context, then it becomes meaningful. So DNA isn't very useful in and of itself unless you put some data to it. So the more data you have, the better the results and the better you're going to find out information. Now, people often complain that, oh, before it used to say I was this percent Danish and now English and now South America or whatever, and then a year or 2 months or later, it'll come back and they'll say, hey, we've updated your ethnicity. It changed. Don't let that bother you, because guess what? The more information, the more accurate your ethnicity gets. So DNA isn't just where you're from, it's where your time and place was. So your ancestors may have been in, say, Europe, and then, say, in the 1700s or 1600s, they may have immigrated to America. So your DNA doesn't really tell you where you came from, it tells you where your ancestors migrated throughout time. And so it's also based on population groups. So if a lot of people in that particular population group have tested and they have their ancestry going to that period, like say 1700s, now you can connect it with people and time. So while DNA doesn't change, the way we interpret it does change over time based on the bigger data sets. So I recommend people do at least 4 to 7 generations if they can get that far, and put as much as you can for autosomal DNA. The longer you can go back, the further, the better. Okay, so brick walls. You can break through DNA brick walls, break through genealogical brick walls by using DNA. You do your traditional research, you hypothesize about a potential, you locate multiple living descendants and look at their trees and see how you might be related with people that are that share the same person in their tree. Now, Ancestry and other websites can do a lot of this automatically for you. They will match, and they have different products, which I'll go over a little bit later. But some of it is, you can almost, it's to the point where you can just spit in a tube, wait a few weeks, and just watch your family tree just sort of populate almost. Ancestry is really good at this. And so I highly recommend you do it. If you have no information about your family, just see what you have. Even if you think you have a lot of information, do it, because you may find surprises you didn't know about. Okay, cousin matches or DNA relatives. They're people that you may have a common descendant ancestor from, and you can compare trees, locations, times, and dates and put them together. Another use of DNA data is what's called chromosome mapping. It's a technique used to determine DNA segments of an ancestor by examining segments shared with another descendant. Once you isolate DNA of a specific ancestor, you can use it to determine which of your cousin matches also has the ancestor in common. So let's say you had an ancestor from Africa and one from Italy, and your match shares a lot of people from Africa. Then you might say, oh, well, this is probably my common African ancestor match cousin. And then there's a website called DNApainter.com, which I highly recommend using if you want to get a little more advanced. But you can say, okay, I have this much from my father, this much from my grandfather, maybe chromosome 1, 2, 3. This part of it came from this person. Chromosome 5, 6, 7, 8 came from another ancestor. And then you can begin painting and see which chromosomes you inherited from which ancestor. It can also be useful in health and genetic testing, because you can find out which ancestor passed on certain genetic conditions, diseases, or strengths. And that's kind of another topic, but it is kind of fun to see it and learn what you can find out. Adoptions. Adoptees and others with unknown parentage can use DNA to find and connect with biological families. The amount of DNA you share determines how you might be related and who on their tree might be your common ancestor. Starting with your close matches, explore trees and identify common ancestors that appear in more than one ancestry. Then search for those ancestors' descendants to find potential biological relatives. All right, I'm going to pause here and tell a brief story. I had a prompting like, hey, you should have your parents do a DNA test. And I thought, that's kind of silly. I've already got my ancestry going back to the 1600s and further. But I decided, why not do it? So I asked my parents to test. Now, the number one rule in DNA is get your oldest living relative to test if you can. And if they're, advanced in age, the earlier the better, because you never know how long they're going to be around. I have some other stories related to that I might share in a different video, but suffice it to say that I asked my parents to do a DNA test. They both did, and within a couple months, I got a message from this person and on Ancestry, and she said, hi, my name is, and I'm just going to use a pseudonym, Jane. Hi, my name is Jane. I was adopted, and the adoption records are closed. I'm 50 years old, and I don't know who my parents are. But guess what? Your dad is my closest match. And I was like, whoa, okay, I better take a look at this. At first I thought, hey, Dad, is there something you're not telling me? But then I realized, guess what? There's two things that are 100% sure in DNA. One of them is you pass on 50% of your DNA to your child. The other one is you inherited 50% from your mother and 50% from your father. Everything else above those generations, grandparents, it could be a mix. From both grandparents, you inherited 25%, but it might be 15 and 10 or 5 and 20. It's random. It's called recombinant DNA. So I looked at this person's match, and she did not share 50% or even 25% DNA. So I knew my father was not the father. So that wasn't really a surprise, but it was, if you understand DNA, you can quickly rule out any of these things that might panic you for a moment. But anyway, based on the amount of DNA she shared, we looked at it and we're pretty sure that she was my second cousin. So my father happened to be visiting for Christmas that year. And I shared this with my dad, and I said, well, who do you think her father is? And he goes, oh, that's easy. It's one of my 35 first cousins. And I was like, what? Well, see, my grandfather was one of 10 children, and each of those 10 had 3 or 4. So by the time you get down to my father's generation, he had 35 or 40 first cousins. So that could be a little overwhelming, but then my dad said, no, wait, look, if she's 50, you can eliminate the older and the younger of the 10 children. We can get rid of those half pretty quickly and eliminate them as a possibility. And then she had told us the state she was born in. So he's like, well, this family went to a different state. We can eliminate that one. So don't worry about that. And we narrowed it down to about 3 or 4 people. And we contacted 1 or 2, and they weren't close enough matched, some descendants. We pretty much narrowed it down to one particular person who the family had kind of lost contact with. We figured that was her father. We didn't ever find out conclusively, but we kind of figured this out. Another story that's kind of humorous is that there was a legend, I'll call it family myth, that in my mom's family, that a particular cousin was like Native American and she was adoptive. And they always said, well, she doesn't look like the rest of them, and we think she came from this Native American family. Well, it turns out we had an aunt do a DNA test. She later passed away, but she shared so much DNA with this person that was supposed to be this person that was supposed to be Native American, that it was impossible that she was not her daughter. So we were like, nope, she's her daughter. She's part of the family. Myth busted. I still don't know why to this day that family lore existed, but you can use it to bust family myths and confirm truths or deny things that are false, So it's good to find out one way or the other. So DNA testing can unlock your autosomal DNA and mtDNA. You can also find out information about yourself, your health, your family. This is a little snippet from 23andMe. They will have ancestry information, genetic health risks, wellness, carrier status, traits, and reports, and other things like that. So another reason to do DNA is to find out which genes might make you more susceptible to certain genetic conditions, health conditions, things like that. All right, so let's go back a little bit about the 23andMe. 23andMe was named that because we have 23 pairs of chromosomes. We inherit 1 copy of each chromosome from each parent, 50% from your father, 50% from your mother. And they're numbered 1 through 23, and they start with 1 being the longest, and 23 is the sex chromosome, and 22 is one of the shortest. And so you either inherit an XX or an XY, 1 from each parent. Now, there are certain genetic conditions where you might have triple chromosomes like XXY or XXXY, those kind of things. But in general, you either have a Y chromosome or you don't. There's no way to get like 2 copies of a Y chromosome because that would mean 2 men. And based on what we know now of biology and procreation, it is a man and a woman to create a child, okay? So without going into more than that, let's just suffice it to say that your father gives you either an X or a Y. If he gave you an X, you're a girl. If he gave you a Y, you're a man. So that's a little bit about chromosomes. A little bit about the DNA testing history. It started in 1999 at BYU, Brigham Young University, Provo, by James Lavoie Sorensen and Dr. Scott Woodward. They did Y-DNA and mtDNA testing. In the year 2000, they collected samples with pedigree charts. In 2003, they moved from BYU to Salt Lake City and worked with Sorensen Genomics, which became known as the Sorensen Database. They collected over 100,000 samples worldwide, and then later moved to GeneTree. 2012, GeneTree was purchased by Ancestry, and then in May 2015, Ancestry shut down the site. And so they still have, from my understanding, they have the database of the raw data they collected. They just don't let people access it or search it. Now, back in that day, in 2000, 2004, they were offering free DNA testing. It was a similar thing. You spit in a tube and send it in and get your results. I did it. It was known as SMGF, Sorensen Molecular Genealogy Foundation. And they tried to get people all throughout the world because they wanted a diverse population to try to understand the human genetics all throughout the world. So that's kind of how it started. So with DNA and DNA relatives, you can find out hereditary conditions, strengths and weaknesses, diseases, wellness reports, carrier status, that sort of thing. You can also find out medication and chemical metabolic information. So for example, people with certain genes can metabolize faster or slower. That may indicate higher or lower doses of medication. Different genetic population groups are affected by the same genes differently. There are other traits such as taste, smell, physical characteristics. There's family history, surname like fatherly and motherly lines, patrilineal and matrilineal lines. And mtDNA and Y-DNA can take you back thousands of years, while autosomal DNA only goes back 6 to 8 generations. So I'm going to pause here and tell you a little bit about the medication and chemical reaction, which is really interesting. I never realized this until I experienced it one time. It was a simple eye test. I was going in to get my eye test, and I have, I call it hazel, kind of a blue-greenish eyes. And I went in to get my eye test, and this was back in the day when they would frequently dilate your eyes. Now, they sort of do that sometimes still, depending on where you go. But now they have computer imaging where they can just flash a picture and they don't have to have your eyes dilated. And the reason they would do that was to check the retinal optic nerve health, the back of your retina. They would put some drops in your eyes. It would make your retina open. And then after a period of time, it would wear off. And during that time, at the end of the eye exam, they would dilate your eyes, look at your optic nerve, make sure it was healthy, see if there was any tears or anything that might indicate you could be going blind or might develop a condition. And I said, well, how long will it last? And they said, an hour or two, and then you should be fine. And so they give you some dark glasses, and I drove home. And it was like, 3, 4 o'clock in the afternoon. And by 8 or 9 p.m., it was still hadn't worn off. And I thought, that's weird. Well, the next year I went in, did the same thing, and I said, how long does it take? And they said, a couple hours. And I said, that's interesting, because last time it was like 8 hours, and it was a long time. And they looked at me and they said, oh, well, that's because you have blue eyes. I'm like, what do you mean? They go, well, people with blue eyes, they don't metabolize this eye drop medication as quick, and so it stays in your system longer, which means it takes longer for it to wear out. And they said, next time you come in, just tell them that, and they'll give you a diluted version that's not as strong, that will wear off in a more normal time frame. And I was like, you guys are the eye doctors. You look at eyes all day long. Shouldn't you look at my eyes and go, let's do that? Why do I have to ask you? The other thing I learned at the dentist. Okay, so I went to the dentist. I'm having some orthodontic work, some cavities filled or something. They do Novocaine. They're getting ready to go in, and I still feel it. And I'm like, that's weird. And they give me more. Well, it turns out that certain people like me, I have British Isles ancestry, particularly Ireland. They metabolize this medication very quickly. And so what happens is your body breaks it down quicker than it has time for the procedure to finish. And so they have to give you extra dosage or give you a little bit more as you're going along through the procedures. A similar thing happens with anesthesia. So knowing some of these traits with the genetics can help you when you go in for medical conditions. So, all right, so we've gone over the names. Now I'm going to tell you what these are a little bit more. The autosomal is the 22 chromosomes plus the sex chromosomes or minus them, depending on which company. You lose 50% of that DNA each generation. So think about it. If you got half from your mom and half from your dad, that means there's half you did not get. And that means your dad also did not get half from his dad or his mother, and so on. So if you divide half, you got 50%, then 12%, then 6%, 3, 1.5, and by the time you go 7 generations, you have very little left to compare against. That's why it's only good for about 6 to 7 generations. However, the other 2 types of DNA, mtDNA and y-DNA, it doesn't mutate very often. The mtDNA is only every 6 or 7 generations it has a possibility of mutating, similar with y-DNA. Now, mtDNA, I just like to think of M as mother, but it actually stands for mitochondria. Mitochondria is a little organism in your cell that gives your cell energy, and that's the layman's term of it. That's my 8th grade knowledge of it. But that DNA, that organism inside your cell has its own DNA. And guess what? You got your energy from your mother. Your mother is the one who passes on your mitochondria DNA, regardless if you're a man or a woman, which means the women pass down the mtDNA. So one might say all women have the matrilineal matriarchal key to the energy in every cell in your body. And the women have that key to the bottom edge. Now, because the man also got it, he can do the mtDNA test also. So either men or women can do the mtDNA test. There's what's known as the HVR1 and 2 region, hypervariable region number 1 and 2. The FamilyTreeDNA.com, which is the one I recommend, they used to do an HVR1 only or both tests. They call it the full test. It used to be like $89.99 for one and then $200 for the second one. I don't know if they still do that first region only, but the both regions is about $100. They do go on sale a little bit, 10, 20, 30%, depending on when you get them. But it does work. I had my mom test, or myself, I forget who it was, but it was one of us tested, and I looked at our tree and I put the mother's mother's mother, and I found a match, and it went back to like 1600, and sure enough, that match had the exact same person on it. And so I do know that it does work. They only have about, well, years ago when I checked, it was only about 40,000 tests. It might have grown even double, or it might be 100,000 or so. I don't know how many people have tested, but it's less people have tested, but it can help you with that one line. Y-DNA is the similar thing, but it's the top edge, where the top is your father and the bottom is your mother. The top edge of your pedigree is your, say, your surname, father's line. Only men can do this, as I mentioned before. You can start with 37, 67, 100, or 700 markers. And the more you test, the more it costs. The basic one, I think, is like $69 or $100. They call it STR, single tandem repeat markers. They go back thousands of years. They change once every 6 to 7 generations. Because it's random, it might change in 1 or 2, but they don't change very often. So let's say you have a lot of Smiths, okay? A very common name like Smith or Jones, and you don't know which Smith descended from which one, because Smith just meant worker. And so in the 1600s in Europe, when the surname system was adopted, it was based on your trade or where you were from or something like that. So just because 2 people worked in the blacksmith shop didn't mean they were related at all. It just meant they shared the same job. And so people often think, well, you're a Smith, you might be related. No, it's based on your profession or something like that. Now, the guy who started it, Sorensen, it's called the patronymic naming system, where they name a child after the father and the mother. So it might be like Sorensen, son of Soren; Jensen, son of Jens; Johnson, son of Johns; Hansen, son of Hans. And so it would change every generation based on the first name and the last name of the person, and he had a really hard time. Just because you have a bunch of Hansens doesn't mean they're all related. It just means they had fathers with the first name Hans. And so Y-DNA can help you sort through that sort of thing on your father's line, as well as the mother's line. So here is a little illustration of what this is. So autosomal is the 22 or 23 chromosomes. It'll go back to 6 to 8 generations. You lose 50% from each. The Y DNA would be your father's line, like this on the left with the males in the blue, and the mtDNA is the mother's line. You notice there are other mothers in pink listed here that you won't find matches against because it's just your matrilineal, meaning the line of your mother's mother, not mother's father's mother or anything like that. Same thing for the father. It's not your mother's father, mother. It's only your father's father. So it only goes this direct line on either the male or the female side. Another way to look at it is to put it on its side. And this is why I say it's the top edge is the blue, your paternal, and the bottom edge is the maternal. Okay. So I'm going to try to do a little laser pointer here. Okay, there we go. Okay, let me go back for a moment. Okay, here's your father's line right here, which is, it doesn't go father, and then mother or something. It doesn't divert over. It only goes a certain direction, okay? Same thing with the women. It only goes mother. It doesn't go father's mother. All these ones that are grayed out. So here is where I say it's the top edge, your father, paternal, great-grandfather, great-great-grandfather, and so on. And then the female, mother, grandmother, great-grandmother, and so on. So it doesn't cover these other grandparents in the middle. It only is the top or bottom edge, okay? So here's a little summary of a chart of costs, how many tests they have on each website. So Ancestry.com, number 1, 23andMe, number 2, MyHeritage, number 3, Family Tree DNA, GEDmatch, and Living DNA, number 4, 5, and 6. So Ancestry has 30 million, 23andMe 14 million, MyHeritage 8 million, Family Tree DNA 1.4 million, GEDmatch about 1 million, and Living DNA only 300,000. Okay, and these are the types of tests that they offer. It says autosomal only on 23andMe, but I think they do offer Y-DNA and mtDNA. They might have that. And Living DNA does all as well. They do Y-DNA and mtDNA. This chart, I needed to update that, but here's a little point I wanted to show here. On the right, the free uploads. The top 3 pay to play. You have to pay to get in their database and in their website. Ancestry, 23andMe, and MyHeritage, you have to pay. MyHeritage used to do a free upload for a period of time, but they've closed that down. Sometimes they'll do it during RootsTech or something. They'll say limited time only, we'll give you a free upload, or they'll give you a coupon or something. But normally they used to, but they don't anymore let you upload. But during their sales, they just had a summer sale and it was only $29 at MyHeritage. On the regular time, it might be $89.99. The standard fee for tests is about $80 to $90 to $100. And when they go on sale, they can go down between $30 and $60. Ancestry sometimes goes to $60. All the major holidays, Mother's Day, Father's Day, Black Friday, Memorial Day, that sort of thing, a lot of these companies will offer sales. And also during RootsTech, depending on which year it is, that's usually February, March, sometime in there, they might go on sale then as well. That's promotional deals. Okay, so Family Tree DNA and GEDmatch will let you upload for free. And I have put on here livingdna.com. I think that's true still. But you can upload, so you test at Ancestry first, download the raw data, and then you upload it to number 4 and number 5, Family Tree DNA and GEDmatch.com. That way you get the most bang for your buck. Now, 23andMe, a lot of people are focused there for health, so you may find genetic usefulness when you're doing genealogy, but if you have to pay for 23andMe or MyHeritage, I would go to MyHeritage just because more people are there for ancestral reasons. All right, here's a nice little chart from the website, theDNAgeek.com, by Leah Larkin. She's been here for many years and does this little chart, and it tells you how many tests that each company has. So about 2017, it really took off. They went from, 2-3 million to like 5, 10, 15, 20. Now they're at 30 million for Ancestry DNA and so on. And you'll see others like Family Tree DNA has pretty much stayed around the 1 million mark for quite a while. They're not going to grow a whole lot for whatever reason. They're mainly focused on Y-DNA and mtDNA. So here's an example of finding relatives on Ancestry. we're going to go over some of the tools on the website. This is an older version of it, but it's a similar thing now. So it'll say, okay, this person has ancestry results, and it'll say, oh, here's the father, here's the mother. That's pretty sure because 3,400 centimorgans. Now, centimorgan, or abbreviation CM, that's just a measurement of how many common strands of DNA you share. So 3,475 range is about 50% DNA. And then there's this little chart over here. I'll go over these charts a little bit later. But the higher the number, the closer the match. The lower the number, the more distant the match. So if you get to like fourth and fifth, sixth cousins, it's harder and harder to tell which cousin you may have come from because it's so far back. And the information gets less and less reliable the further back you go. So here's a nice little chart from Blaine Bettinger. He's also really famous for doing DNA stuff and explaining it. So this little chart here, he's got little numbers on it in the upper right corner, which is percentage of DNA, like father 50%, mother 50%. So it's got 50. So 50%, it tells you the number of centimorgans, shared DNA segments. It also depends on group dynamics. They call it endogamous populations. They can intermarry each other over generations that can kind of skew this number, such as Jewish populations, Icelandic, island cultures that didn't travel very far or had limited people to marry and intermarry with. They might show that they're more closely related than they really are, just because their genetics didn't differ as much. So you also have to take the historical and population context into account when you're looking at your results. So for example, 1760 is the average for grandparents. And there's a range, 875 to 2365. You might have higher or lower numbers, but the average is 1760. So if you come up with that, you know it's probably either a generation up or a generation down. Up, grandparents; down, like niece or nephew. So you notice here it has 25% in the corner. So 25% on average grandparents, and then 12, half of that, great grandparents, half of that, 6% great grandparents. So you lose half every generation. And you notice you have similar numbers down here as you go down in the relationship. Anytime you put a mix, whether it's it's a spouse or a child or whatever, it degrades the amount of DNA you would share by half. Okay. And then this other chart over here, it's got 1C, which is first cousin, 1C, 1R is first cousin once removed, first cousin second removed. So if you share the same grandparents, here's yourself in the middle, your father and mother, and your aunt or your uncle is the sibling of your parent. And if they have a child, that's your first cousin. So that's pretty easy. First cousin, you share the same grandparent. Second cousin is you share the same great grandparent. So if your common ancestor is way up here and 12.5% average, then you have the second cousin on the right. And so on. If you go great grandparent, it's third cousin, and so on. So the further back you go, the more cousins you are, and the more removed you are, it's a generation removed. So that's a little bit about that. So now let's look at the matches for Ancestry DNA. So Ancestry, they have these different options here. They have summary, origin, matches. So if you click matches, you'll see this all matches. You can do it all, or you can do it by parent, by ancestor, by cluster. That's a whole nother topic. By location, geographic location. So you can do filtering of your matches. So on the left, it'll say close family. It takes the closest ones first and then expands them outward from there. So the further down the list you go, the more distant you're related. So it has a percentage of DNA, and it also has a number in CM, or centimorgans. And it also, if you've had both your parents test, they can try to tell you if it's your mother's or your father's side, even without your parents testing. But based on how many people in your tree have similar matches and similar names, they can kind of figure out some of that. If you have your parents test, all the better. This one says my maternal side, and it's 434 centimorgans, which is about 6% DNA. So that's either a first cousin once removed or a first cousin, something like that. And then you notice on the right here, it says unlinked tree. So this person, Wendy Christensen, has done a DNA test, but she didn't put a tree in, didn't link it. I happen to know it's the father of Charles LeGrand Straup. This person's father which is my grandpa's brother. So I know she's my first cousin. And based on her age, she's one generation removed from me. And so that's how I know that. And then as you notice, as you go down, you have 434, 395 centimorgans, 380, 377. So you go from 6% now to 5%. And what you want to look for if you're trying to find ancestors is you want to look for this column of trees. Unlinked tree, you can sometimes click on their profile and find their tree. They may not have linked it to their DNA. Some people will do that. They'll upload a tree, they'll take a DNA test, and they don't realize they have to link the two to be successful and to be helpful. And so they'll just leave it unlinked, but you can just go in and manually look at it. If it's linked, then the site gives you more information. Also, there's this point over here on the right that says add, and you can create little groups. So what I do is I create the blue groups for the paternal and then the pink for the maternal. So you notice it says paternal here, and then it has maternal over here for the mother. So this helps you kind of slice and dice your matches. You can filter based on these groups you create. This one here, Karen Card, she has publicly linked tree, 2,400 people. If you find someone like that, chances are you're going to probably be able to narrow it down pretty good how you're related if you have enough DNA, like 5%. Okay, so then you can click on the person's name and you can see what matches they share with you also. So if you share common ancestors with the same person who's a DNA match, then you pretty well can tell you that's part of your ancestors. In this case, she has an unlinked tree, as I mentioned before. You can put in notes like the father is so-and-so. You can put a little note on your match, which is very helpful. Those notes are only for you to see, but it's a nice way of helping you do some research. Then you can click shared origins. So like this person, Wendy Christensen, and I, we share she has 22% Norwegian, I have 15%. I have 29% English, she has 11. So here you can see right off the bat, our common ancestor is probably someone from Norway because we have a really close amount. It might be from England, but it's just not as close of a relationship because it's 11% versus 30. And same thing with Northeast England. My ancestor is not from Northeast England, it's 2%, where hers really are. So if I find someone on her tree that's Northeast England, I can probably eliminate that as my ancestor because it's probably not very likely. Netherlands, more likely, it's got 2 and 3%, and so on. So like here, it says Denmark, 15%. I'm 15% Danish, but she has 0. So if I'm looking on my Danish side, don't even bother for this person because it's not going to be there. So when you see 0, that's a real great way to just eliminate it. Same thing with here, Southern Germanic Europe, she has 20%. I have 0. So don't look in the Southern German Europe part for your common ancestor because I have 0 of what she has, and so on. And on the left here, you see the groups that I was mentioning. You can do a starred match. You can do just colors. You can add and delete. So my paternal, I've got 46 people that I've tagged with the paternal and 38 with the maternal. So then you can filter on that and help you find more information. Now I'm going to talk a little bit about shared, through lines. So through lines are really helpful because if you identify your grandparent, third, fourth grandparent, you can click on it, and if anyone else has that same set of people from you to them in their tree, it'll say, hey, this is a common match. So in this case, my ancestor Jesse Hyatt, he had I didn't show the whole width, but he had 10 kids also. You notice Matilda, it says 26 matches, Jacob 9 matches, William Hyatt 180 matches, DNA matches. There's 180 people who've taken a DNA test who have the same person. Whereas Matilda and Jacob is only 26 and 9 descendants from those people. And so this is a really great way to kind of help you just pretty much build your tree for you. If you put in enough information and you share DNA matches, it'll start building the tree. And you can go sideways, left and right. You can go up and down the generations. It's a really great tool. Here's an example with my third great grandfather, Ransom A. Stevens. I clicked on it and I can see he's got 39 matches from Elizabeth Tabitha Stevens and only 2 from Lindsay A. Stevens and 3 from Lois A.S. Tanner. So basically, yes, I'm descended through this Elizabeth, who has the most common matches, and so on. And you can find pictures of maybe you've never seen before, family gatherings, all kinds of treasures that might just pop up. They used to call it DNA circles. They've changed it to through lines only. This one says I have 105 matches from my third great grandpa that have taken tests. Now I'm going to switch over to Family Tree DNA just for a moment to show you some of the things that they have, which is really nice because they have things like X matching. X meaning your mother's side. Well, also the father has an X because he has an XY. He has an X and a Y, whereas only the woman has the X. She has two X's. So if it says X match, this one says linked relationship. I've linked it. It's my mom. But I put in ancestral names that descend from and so on. You can kind of click the links and start linking them up. They have trees. They have since migrated their trees over to, I believe it's MyHeritage. They used to have their own little tree browser. They still have it for legacy support, but they're encouraging people to link over to another third-party site. There's another one called Geni.com, Geni, that is really good because it's like a free open public database connected with your DNA. I won't go over that today, but you can connect it with several other trees. And by connecting the tree with the DNA, that's how you can figure out how you're related. The nice thing about the Family Tree DNA experience is they have paternal, maternal, or both tabs. And you can say all, or you can split it out by your father and your mother and look at those relationships. Here you can see I have more than twice my relationships with my father than my mother. And so you can do a little bit more. They also have what's called a chromosome browser, which is really nice. Family Tree DNA allows you to download segment data, which is DNA information on the segments and which parts of the chromosomes you inherited, which allows you to start doing chromosome mapping. Okay, so yeah, and you can do surnames and advanced searching, and they have all kinds of things. The interface is a little kludgy, but it works, and it does take a little bit long. This is a chromosome painting from DNA Painter. Okay, so what you do here is you download some data, you download your segment data, and then you upload it to the site, and then you find another match. You download their segment data from another website like Ancestry or Family Tree DNA. You download each of your matches' segment data, and then you start overlapping it and see, okay, this is my great uncle Ernest Jones, the brother of my grandmother. He's deceased, but you can see this blue. So you can see I inherited chromosome 1, 2, and 3, and he has a similar area of the chromosome that I also inherited. Okay, so but then you look at the red, which is my son, and then the blue, which is my mom, and you can see like what parts they overlap and which parts they don't, and you can kind of start figuring out which side of the DNA came from which ancestor. So here is the Y-DNA interface. So this one is pretty neat because this is where your Y comes in, the father's line, the father's father. So I did a Y-DNA test. I clicked the group matches. It has this genetic distance on the left with the names of people. So generally your surname is your Y-DNA. So you notice I've got Hyatt, H-I-A-T-T. I also have B-I Hyatt, B-A Hyatt, H-Y-A-T-T. And then I have this Douglas Allen Anger. And it's like, oh, wait, he's not a Hyatt, but oh, guess what? He probably had what they call an NPE, a non-paternal event, which means there's an adoption, a birth out of wedlock or something where there was a name change. But he really was a Hyatt genetically. He descended from someone who was a Hyatt. And somehow his name got changed through adoption or unknown parentage or something else. So don't be surprised if you see surnames that don't match yours. This is actually really good. And guess what? Your surname system started in the 1600s in Europe. China had it for many years, thousands, I guess. China was one of the first to do the surname system. But in Europe, it was only 1600s. So like I said, you might have two Smiths that are not related at all, and you might have a Smith and a Jones that's related because they were brothers. Or let's say Smith and Cooper. Cooper meant barrel maker. So a Smith and a Cooper, one might have worked in a blacksmith shop, one might have worked in a barrel making shop, but they're brothers and they're genetically related, even though they have different last names like Cooper and Smith. And so you have to understand the context, like I said earlier. But now I'm going to go over this Y-DNA haplogroup. So a haplogroup is just like a population group, and there's a whole tree. You can kind of figure out what your haplogroups are. But if you share the same haplogroup, like this one, RU106, that one is pretty recent. That means I'm definitely descended from this guy, B.A. Hyatt. I since have found out how I'm related. Roger Lewis Hyatt was my great uncle. And you look at the ancestor, John Hyatt, 1696. So I happen to know, yeah, this is my ancestor also. I also share a lot of DNA. I know who he is, but he's the M269 group. I can tell you when it matched. The trees, it's called the haplogroup tree. That's probably a topic for another video because I'm running out of time, but that's the concept. They also have these ideas of surname groups you can join. And when you join them, you can see which segments of the DNA, which bits you share. Oh, and I forgot to say this genetic distance, 2 or 3 means it mutated twice. And so we probably have an ancestor within the 1600s or maybe the 1200s. So unless your tree goes back to 1200, you may not ever figure out how you're related, but you are related and you can look at their trees and compare them. And there's a way to put in unknown ancestors and try to figure out that, which is part of the DNA painting. All right, so this is an example of a Hyatt surname group. So it might be Smith, Jones, Jensen, whatever your surname is. You can join groups if you have a surname group. You can filter by markers. I'm filtering by the 37 marker test, which is the cheapest one, the least amount. And then you can see where the difference is. So in this case, this Phillips, Joseph H. Phillips ancestor with a HYATT, he had a difference in this chromosome marker 458 and number 19. Everyone else had 18. So that's why they're grouped together. So it's lineage 1. In the lineage 2, you notice there's these numbers, but this one has position 458, it has a 17. This one has 18, 17. And so the more differences you have, or if they're all similar, that means they descended from the same parent, the same lineage. So you start grouping them and you can kind of figure out which ancestor came from which person, which is kind of neat. So now for the mtDNA, it's a similar thing. I also should mention on the right, you see FF, which is Family Finder. I forget what the FMS is, but anyway, it tells you what type of test they've taken. So this is HVR 1 and 2 coding regions, which I mentioned earlier, which is both. And you have genetic distance 1 and then 2 and further on. So you want to look for the lower genetic distance. If it says 0, great. You know you have direct match. 1 is, okay, maybe 1 mutation every 6, 7 generations. Chances are you have a common ancestor. And mtDNA has haplogroups also, like this H6A1B3. It's just a population group. You might think of it broadly as like, okay, I have African ancestry, I have European ancestry, I have South American ancestry, Italian, whatever. That's kind of like a haplogroup. So haplogroups are genetic population groups. If you share the same haplogroup and low genetic distance, means you're really closely related, you've probably found something. And if you see the little tree icon, that's good because you might look at their tree and then see if you have the same person on the tree. So also, just to wrap it up here, 23andMe, Family Tree DNA, and Prometheus. Prometheus, you can pay $25, download your raw DNA from a site like Ancestry, and then upload it and get reports, which is really good. It'll tell you about things like I was mentioning earlier, genetic conditions, disease, metabolism, cancer risk, all kinds of things. You pay a one-time fee for $25 and that's it. There's also a website, xcode.life, which has FDA-approved reports. And then there's a website called SNNpedia, which is kind of like the Wikipedia for DNA. And so you can go there and you can search for something like, okay, resistance to disease. This is a positive thing. If you have this gene and you have a TT on this position on chromosome number 11, you have less susceptible to infection with bacteria, tuberculosis, pneumonia, etc. So they tell you like, okay, your genes do affect how you catch diseases. One last example here, glaucoma. This particular chromosome, let's see, it's chromosome number 15 in this position number, 21,65241, has a C and a T, which is a 4.4 increased risk for exfoliation of glaucoma. Now, glaucoma is where you can go blind. So interesting story here. My father-in-law has this gene. I had him test. He has this also CT, which is increasing risk. On the bottom right, it has a chart. So 0 is normal of CC. If you have a CT, you have a 2.2 increased risk. If you have a TT, you have a 10x greater than risk for glaucoma. So you really want to find out, what do you have on this position? So my father-in-law had, 65, 70, he was pretty healthy. He started developing a little bit of pain. Normally glaucoma is pressure in the back of your eye. They call it intraocular eye pressure, and you may not feel it. Most of the time people don't feel it. This case, he didn't really feel it, but he started having headaches. Well, that was because he was losing his vision. He went into doctors. They couldn't tell him what was going on. Next thing you know, he went blind in one eye before they could do anything about it. And, actually, he said he was experiencing something, and they looked at it, and they started giving him drops and stuff, but it wasn't a lot they could do, and he went blind in one eye. So I had my son test, and sure enough, he has this same gene. So now I can tell my son, hey, when you get to be older, make sure you do your eye test, do your glaucoma check, a little eye puff pressure during your exam, because guess what? You have an increased risk. So this is another reason to do DNA. Another one is unlikely to go bald. I have a TT, unlikely to go bald, and it's just a percentage. You can download your raw data and put it in a spreadsheet. It looks like this: chromosome, position number, and result. I'm not going to go over that too much, but suffice it to say that your DNA is both like the hardware, and then epigenetics is kind of like the software. And the software can be turned on or off. Your genes can be turned on or off by environment, behavior, like smoking, that will turn on genes that turn into cancer, for example. They've done tests and shown like two twins, genetic DNA identical. One will get cancer, one won't. Why is that? Well, because one smoked and one didn't. So the diet, exercise, environment, and other things can affect your health and the way you experience life, and even the way you taste things. Hope you've enjoyed this presentation. Thank you for listening, and tune in next time. Have a good day.